Okay, so we are going to look at the derivatives of inverse hyperbolic functions, and what we look at in this case is the is the hyperbolic cosine. So let's say we are given a function y is equals to hyperbolic cosine inverse of x. So same procedure as the previous one. We're going to have our x being equals to in fact we're just going to let x be equals to that. So we're going to have our hyperbolic sine of y, and what we do here is that we find the d dy of both sides. Okay, so we're going to say d dy of x is equals to d dy of hyperbolic cosine of y, and what you're going to get is here you're going to get your dy, no, not dy, but dx dy is equals to hyperbolic sine of y. Okay, so once again we just go to the identities, but before that we'd want to have an expression for dy dx, which is dy dx will be equals to 1 over uh, hyperbolic sine of y. Okay, so from the identities, we know that our hyperbolic 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 sine squared of y will be equals to uh, our hyperbolic cosine squared of y minus what, minus 1. So meaning our hyperbolic sine of y will be equals to the square root of uh, hyperbolic cosine squared of y minus 1 there. But before I do that, I want to find out what my x is. I mean, what my hyperbolic cosine squared is. When you look at this part, we have our hyperbolic cosine. So if you say squared, mean even the x is squared here as well. Okay, because if we put a squared here, even here to be what, a square like that. So what we have here is a what, is our x squared minus what, minus 1. So meaning the expression for dy dx will be equals to 1 over uh, 1 over the root of, okay, the root of x squared minus what, minus 1. All the same here, the x is just simply a u, it can be anything, so it says u prime. We differentiated x, the derivative of x is 1. That's why we have a 1 on the numerator. Then here we have what, our u squared, which is simply our x minus our 1 here. Okay, and this is simply the what, the standard equation for the derivative of uh, hyperbolic cosine inverse of x. Okay, so remember to say our u can be anything. You can just have to replace there. So once again, the key thing is to just remember how you come up with these, like how you come up with what we have here from what you have here. Because let's say you forget, like you're writing a quiz, a test, or something, an exam, you forget how to come up with how to move from this to that, or what that is equals to that. Meaning, if you know the steps, you're able to do it on your own. Okay, because in mathematics we don't have to memorize things. We have to understand why it is true and being able to derive it on our own. Yeah, so that's all in this video. Thank you very much for watching.